Hello, my name is Dahan Yılmaz. This is my EE102 term project presentation. This project of mine is actually a continuation of my Physics 101 project. And to summarize my Physics 101 project, I dropped a table tennis ball from a certain height and measured how high it bounced back. And I did that many times in order to collect experimental data to derive a certain formula that predicts how high the ball will bounce back when it is dropped from a certain height. I couldn't manage to derive a certain formula because I couldn't measure one of the important factors that affect the final height reached after the bounce, which is time. I couldn't measure the time because back then I did not have the necessary instruments that would measure the time accurately. But now with a combination of bus history and a voice sensor and appropriate VHDL code, I can make such an instrument. For design specifications, I have a 7-segmental display which counts the time in milliseconds. I use the 3 leftmost LEDs to indicate whether there's a bounce or not. It's gonna always light up and down as I'm talking because I generate voice and the voice sensor senses that. And I use the 12 rightmost digits to determine the time. These times are in milliseconds and of course in binary. So this indicates the first time of the first voice input, second one, third one, and the fourth one. To analyze the experimental data that I derived, I created a Python program. This is the experimental data that I derived at Physics 101 and I'm gonna implement it in the Python code. This Python code has 2 modes. One for plotting existing data, which I'm gonna do now. Initial height was 200 centimeters. I know the time, so I will input invalid outputs and it will plot the data for me. Those height versus bounces, height ratios, or ratios of excessive height losses are all the things that I made up in my Physics 101 project, but they are all valid and shown on this graph. The other function of my Python code is actually the important one. It derives and plots the data from the limited data that we have, and the limited data that we have is from bus history. The times of the bounces, which is shown here in binary milliseconds. I'm gonna do an example now. I'm gonna drop this ball from a certain height that I don't know. It recorded 4 bounces and I'm going to input the times of those 4 bounces. I'm entering the first one right now. The initial time doesn't matter, only the time between each bounce matters. So this is the third one. Fourth one. I didn't measure the initial height that I drew from, but the program I designed predicted as something around 35 centimeters. I imported a formula from a physics paper of Marquette University, and the paper stated that it has around 15 to 10% error rate, but I think it's accurate enough for my case. It has also the other ratios, but it doesn't show much because there's only 4 bounces, so some of them are just registered as 0, which is intended really. One of the things that I want to talk about is the debouncing logic, because it's a bit different from what is commonly used. When I took lessons for debouncing in VHDL, the ones that I came across were mostly for push button debouncing, which is a bit different. Because in the case of push button, when the logic stays at 0, button is pushed and there's a very short unstable state, then it keeps being at 1 for a certain amount of time, which is not the case for voice sensors. In my voice sensor, because it's just a table tennis ball bounce, it doesn't last long, so after the unstable state it just keeps being at 0, which is the main difference. To solve this, I used a finite state machine with 2 states only. one state was active, the other one deactivated. The voice sensor stays at active state for the most of the time, but if voice sensor receives a rising edge, it takes that data, it accepts that data, but it goes to deactivated state and stays there for 0.2 seconds. That 0.2 seconds is a bit arbitrary. It could be shorter or longer if it meets the requirements, but from what I observed, the unstable state in the case of voice sensor is very long. When I tried to reduce it to 0.05 seconds, the bouncing didn't work properly, so that's why I picked 0.2 seconds. That will be all for my presentation. Thank you for your patience and thank you for watching.